So here we're going to differentiate the arctan function. So we're going to apply the same process. We're going to rewrite it in terms of the tan function. Okay, so the y is the arctan, or the angle. So we put tan of y equals the x, which is the ratio. Okay, so we're going to differentiate this implicitly. We get secant squared y times y prime, because it's an embedded function, equal to 1. We're solving for y equals 1 over secant squared y. Okay, so we want to get rid of this expression here, and we want to try to get it back to x. The way we do that is we're going to relate it to that. So we know that secant squared y must be equal to 1 plus tan squared y. So I'm going to replace that with 1 plus tan squared y, and we've defined tan y up here as x, so we're going to replace that tan y with x, and we end up with the expression that we want in terms of the x. So we end up with 1 over 1 plus x squared. Okay, so what that means then is, what that implies then is that the integral of an expression that looks like this, when we have 1 over 1 plus x squared, we can't use power rule or anything like that. So, but this relates to an inverse trig integral. So we end up with tan negative 1 of x plus c. Okay, so this is now a defined integral. Whenever you see those relate to the arctan function. And again, I'm going to show you another one here, which is more of a generalization. Now, again, I'm not going to elaborate on how we get from here to this expression. This becomes 1 over u, or 1 over x, arctan x. So 1 over a, arctan x over a plus c. Okay, these are ones that we should now have as our standard integrals. Okay, and it comes from, we also can undo ones that look like this. Okay, so so just to be clear, these two now are standard integrals. When we see these ones, we can't use substitution in here, it won't work. We have to apply the arctan antiderivative. So we're going to differentiate cosine as well. Okay, so we end up doing this, we're going to do the same thing. We're going to say cos y equals x. Differentiate, we end up with negative sine y times y prime equals 1. Y prime equals 1 over negative sine y. Again, we know that sine y is equal to 1 minus cos squared y, square root. Okay, we're going to substitute for that. So we end up with y prime equals 1 over negative square root 1 minus cos squared y. So just like in the other examples here, we can replace that cos squared y with an x, and we end up with y prime equals 1 over, I'm going to put the negative up there, 1 minus x squared. Okay, so this one here, if we just look back at sine, really it's kind of the same thing, it's just that it's negative. So when it comes down to the integral, we could technically say that the integral of the negative form of this is equal to the arc cos of x plus c, but really we don't really need this one and this one that we've generated here. Okay, in fact the negative is not very useful. So what we're going to do is say, well, although this is true, we're just going to stick to this. We're just going to say the negative, and if we integrate that, we're just going to end up with negative arcsine. That's much easier, so that way we don't have to use two different ones. Okay, so we're just going to stick with this one. Although this one does exist, we're not really going to use that one. Okay,